Okay. Okay, guys, let's continue and finish the basic workshop. Today, talking about CakePHP unit testing. Is there anyone here not unit testing his code yet? Okay. Okay. Today in the basic workshop, we're going to deal with model unit testing. If you're following the good practice of putting all your business logic into the model layer, and you unit test around, let's imagine that 80% of your code is in your model layer in a great scenario. And let's imagine that you reach 50% coverage in your model layer code. So you are getting a wonderful 40% coverage in all your application. So this is one of the reasons. And the other reason is testing the model layers is much easier, because models usually only depend on other models and maybe some behaviors or other kind of libs, but they don't have a lot of dependencies between other classes in CakePHP. It's not like a controller that has a lot of dependencies. And when you unit test your code, you need to take care of those dependencies so you are not testing code outside the class you're trying to test. So yeah, the third point here is unit testing actually is spending less time in the product development in the long run. Keep in mind that when we develop an application, there is a maintenance, there are bugs, there is a full life cycle there. So if we think about delivering code, doing unit tests will be slower for us because we need to write more code before delivering the thing. But if we put ourselves in the client perspective, he doesn't want to pay less for the code. He wants to pay less for the product. And the life cycle a product has includes the maintenance. And if you already did unit testing for your code, you are getting rid of a lot of stupid bugs, and you're also providing good practices in the design of your current code. So you are building code that you will maintain easily in the future. And this is also good for the client because you're spending less money in typing and more in providing a good service. So we're going to test our brand new answers homepage, but we don't want to test the controller, so we're going to refactor that a little bit. I don't know if you ever did that with a custom finder, but let's do it now and refactor the answers home and provide a custom finder to retrieve that. I'm gonna do it really quick because we are like getting short in time, so I want to cover unit testing for sure. The first thing about unit testing, well, we need to do a couple of setup items here because we need to install PHP unit that is not installed yet, but we're going to do it in a few minutes. The first thing here is, let's take a look at this code. Okay. Oh yeah. Answers. Okay, we have this function here, but we don't want to test the controller at all. So we're going to move this into a custom finder in the answers model. You were doing this a lot yesterday, so you think you can go ahead and start doing it? I'm going to do it as well, but try to do it. Don't look at the at the screen. Just try to do it yourself. So we are going to change this and use this. Find home. Right? And once we get there, right. So what should be the name of this function in the model? In the table? You How does this function start? Okay. Something like that, right? Super easy to have. It's like one of the custom finders we were playing with yesterday with Jose. But super simple, because we are just getting a limit, getting an order, sorry, setting a limit and order, and defining some contain there. We need to send to the view. We need to remember here that we need the organizations, right? To make it work in the view. So yes, well, if we run the home page now, we should get the same. Right? So first thing, we start thinking about unit test, and even right after we start thinking about unit test, refactoring is coming to our mind too. And because we are super lazy, we don't want to test controllers. We want to test models. And because of that, we did a refactoring, a very tiny one, but we did a refactoring that is actually good for our code, because we moved all this logic into a custom finder. So now we have this custom finder available for other actions or models or composing this custom finder with other finders to build better queries or require queries in the future. So actually this is good because, well, we started with unit testing. We didn't unit test anything, but we just did a good thing for our code. We improved our code thinking about unit testing. And because we are lazy. So the next thing we're going to do is, the next thing we're going to do is to set up PHP unit. Setting up PHP unit using Composer is a piece of cake. Did you ever have issues setting up PHP unit with peer? I did. By the way, for 2.0, I ended using a CakePHP plugin. I think it's dear Mark. Is he around? Is yours, right? The PHP unit plugin for 2.0? Yes, yes. I've used that one sometimes for 2.0 projects. So we need to do it this way. And, well, add this require line to the Composer JSON. It will take care of downloading things and installing things. So hopefully we have a super good network now, and will take, what, a couple of seconds. Meanwhile, okay, yeah. So, what CakePHP does for helping us with unit testing? Well, it gives us the ability to generate some code using the bake shell. So we don't need to start from scratch when writing our tests. We can go to the console and we can generate those skeletons we could use for start testing. At least we don't need to type so much. They are already there because every time you bake a model or a controller, or the fixtures and the tests are already baked for you, and they are placed in the right folder. But we are going to bake them again, so you know. And it provides a test data source, so you don't have your data source, your database configuration there, and it provides another database configuration for you. So when you're testing, CakePHP will detect you are unit testing and will switch to use a test database, so you don't have any kind of issues with your real database. Also provides fixtures. Think about a fixture as a way to represent a specific status in your database. It's like a fake database where you can manipulate the data very quickly because it is in plain PHP files. So you can decide what kind of state you should have, and it is a stable state in your database when you start testing something. So you don't need to worry about a previous test changing the data you have in your database, and then after that change, you need to react about those changes. You don't need to worry about that. Every time a unit test method starts, the database is exactly the same. So those are what the fixtures are used for, to define the database status so you can test in a reliable manner using the same database that is state every time. Okay, so once PHP unit is installed, we are going to start baking. Well, the first thing we are going to do is to configure our test database. What? Oh, I need to define that now? Please, no. Oh man. Okay. Are you having the same issues?
Yeah.
Well, if I remember correctly, you need to go to the GitHub page.
Just log in.
Huh?
Just log in.
Oh, just login. Well, I was about to show you how to use the auth token, but do I remember my password? Possibly no. Yay. So this gives there. In the password. Give there. And should work. Yeah. I'm gonna send you with the slides. No, based on my GitHub account. Your GitHub account, username and password. Okay. So Composer did install those files, and those files are installed in the vendor folder. So now we have PHP unit available through this shortcut here. Bin PHP unit. Okay. That's right. Okay. Also, CakePHP 3 is using a 4.2 version of PHP unit. Remember, CakePHP 2.0 was in 3.7, if I remember exactly, 3.72 or something like that. So yes, it's installed. Okay, let's configure a test database for this session. We have the regular configuration, and we have sorry, the test connection that we are going to set up right now. And password and database. Right? Actually, database does not exist yet, so let's create it. Okay. So now we have a database, and it's empty. So first thing is, we're going to use Bake to build a test skeleton for our answers table. So we can use Bake as we did before. console cake bake. Well, you know, baking 3.0 is does not have this interactive mode, but it has a very good help, context-based. So you can bake a test, and I'm going to test a table, and I want to test the answers table. There we go. Override yes. And we baked we baked a new skeleton for our test. Let's take a look at how it looks. Well, this is our test. It has 3 different things in our test. There is first the fixture declaration there. This is where we say the fixtures we are going to use in this file for all the text or for all the tests we have. So we really need only the answer, the user, the organization. This is not needed. This is needed. I don't know if this is needed or not. And questions tag is not needed. Okay? I think will work this way, but if it doesn't, he will tell me, hey, missing table. I'm trying to look at one table that does not exist in your database, so please provide a fixture for it or change your code. So the second area in our unit test is the setup and teardown methods. For every single test we add, before the test is run, we are going to execute the setup method, and after the test is done, we are going to execute the teardown. So we can add there any initialization or cleanup code we want to keep all the tests isolated. It's very important that we don't modify things that another test could take for granted and then fail. We're only using in the setup method, we are only adding an answers table here that is just using the table registry. You remember yesterday, Jose used table registry like 1,000 times or so in the workshop. So remember, this is the replacement for the class registry, and it's the specific factory for retrieving tables. Okay, so we are just getting the answers table, and we are adding it so we can use this answer table later in our test, whatever we want. And because we have one public function in the table, the bake has created this placeholder for us to remember that we are not testing anything yet. So that's true, actually. Let's run this test and see what happens. We're going to use PHP unit to run this test. We only need to provide PHP unit with the full path to the file. src, sorry, as in test case, okay. Case model table, answers table. Okay? And this is the actual output of PHP unit because we only have one test method and it's not even implemented, so we are getting a warning. Okay, but incomplete one. You remember in CakePHP 2.0 we had a specific test shell we could use to wrap PHP unit, and this is no more. We now have the PHP unit there to use it as it is. The next thing we need to do is, well, to actually start testing our code. I want to show you how to use fixtures with this text. So we are not mocking anything or things like that. We are just going to use fixtures in our database, and we are going to test the result is what we are expecting based on those fixtures. So let's take a look at the original code again. Where you are? There. Okay. So imagine that we are going to test the findHome method. We are going to use fixtures for testing it. So we are not going to we're not going to do mocking of anything. We're just going to retrieve the real fixtures from the database and then expect what should we have there. So first we're going to check how those fixtures look like, and then you're going to tell me how should we expect when we run this finder against those fixtures. Okay? So let's start taking a look at the fixtures file. Fixtures are located here under the fixture. We don't have fixtures, so we need to bake them. Sorry. We can use bake to bake a fixture. Fixture and answers. Okay? Oh, is there? Override. So let's take a look at it. Okay, this is how a fixture looks like. It's a little bit scary at the first time, but you can safely ignore the fields for now. So the only thing here we need to take care of is, well, extending test fixture, and the fixture is like anything we need to know about the table to create a new table on the fly. So we need to know the schema of the table that is there in the fields. You see, if you read those fields, there is one element for each of the fields we have in the answers table in the database. And everything we need to recreate this table is stored there with the syntax. For example, question type option ID is an integer, has length 11, is unsigned false, etc. Okay? That's the first part of our fixture, and the second part of our fixture is the actual records. So once we define the schema of this table in the fixture, we define the contents we are going to have. And Bake will generate this kind of lorem ipsum contents for our string fields or text fields. And we'll start, all the integers will start in 1 and then go 2, 3, 4, 5. So we have some placeholders here we can use for editing data. Okay, we have 3, 4, 5, 6, whatever. So when we use this fixture, we will have 10 rows in our answers table, right? Because there are 10 rows here. So for every single test we do using this fixture, at the beginning of the test, we will have those 10 rows with exactly those fields and those contents.
On the test database.
On the test database, of course, yeah.
This is like a snapshot of real data because we got this information from our production database, right?
Actually, you can retrieve real data from the database to build your fixtures. But this is not a snapshot, this is generated code. This is fake, totally fake. But yeah, from 1 to 10 and lorem ipsum on all input text. You see, if we check the looks like right, but it's generated code. So if you have a very complex, or if you really need to use similar data in your fixtures, there is a way to let the fixture import this data instead of using records. But we are not covering this today. We are going to focus on the basics, so you get a clear picture of what we are doing. So yes, every time we start a test, we have 10 rows there, and with those values. Once the test is finished, everything vanishes, and when the next test starts, we get again all those 10 rows with exactly those values. So if we have a test that is doing a save operation, the save will be done to the test database, but when the next test starts, those data, the data will be reset to the value in the fixture.
Do you have to manually, I didn't see that, do you have to copy the structure manually, or
Copy where?
table structure or answers?
No, this is Bake who's doing it for you.
Okay.
If you bake that, Bake will go to your database, will read the schema, will use the same schema, and based on the schema, will generate 10 records with lorem ipsum.
And what about the tables? Who's going to make the tables in the test database?
Oh, the test suite. I mean, when you run the tests,
It will copy the structure and then insert?
yeah, automatically this is provided by you. You don't need to worry about that. Huh?
Delete the table again?
Yes. I think it's truncate what it's doing, but it's okay. Yeah, that's the idea. You have a stable state in the database, something that does not change between tests. So you can think about the tests in a reliable manner. You don't need to worry about if you add a test before the test I'm writing, everything's gonna break because I did save whatever, and I was expecting there to have 10 rows, and now I have 11 rows, and everything is blowing. So this is, okay. So now we have 10 rows, right? And the next thing we're gonna do is run the test again to check everything's working or not working yet. Right. So next thing is well, start writing the test itself. So what should we do here for testing this thing is working? Test case, model, table, answers. Right. Okay, so if you want a standard approach for writing unit tests, you first should configure what are you expecting to retrieve. Then you need to run the code you want to test. And then you need to get a result after you run this code and compare your result with what you were expecting at the beginning. Okay? So this is unit testing. So first, what do we need here? Well, one of the things we need to do is to actually call the code we want to test. How could we do that? Anyone? Yeah?
The expected or the result I would call find, this would be custom find on the model, so it'd be this answers table find, and then whatever the name of your custom finder is.
Right? So find home, right? Okay. So we are testing a custom finder, so, well, this is not super strictly calling the code you want to test, because we are not testing the find function, we are testing the custom finder, but I think it will work for today. Just keep in mind that we need to run the code we want to test. So we can run it this way. Okay? And we get a result. We don't know what result is that, so let me debug this result and see what happens. So running the test. Ooh. Okay, I need the questions. No problem. Here you go. Possibly I will need the other one too, but oh yeah. There. Okay. Thank you. So I'm debugging the result I'm getting, and this is the result I'm getting. You remember, it's a custom finder, so we are not getting results. We are getting a query. So that's a query. Okay? If I want to debug the results, no problem. I can go there and say something like this. How should I do it? What should I put there? I want to get the results. Sorry? To array, yeah. But I don't want to get the entities. I want to get a plain simple array. With a collection you will get the, yeah, I mean you can extract that using extract, yeah. But there is a simple way. We discussed about that when dealing with the queries. Yeah, why not? Yeah, we already got the results. We executed the query, but we don't want to have the entities. We just want an array. Now yeah, we could do this. We could do it this way too, but I was thinking about hydrate. You remember that? Okay, and then to array. If we do it this way, the query will be executed because we are doing to array, but because we configured hydrate to false, we are not hydrating the entities, so we are going to get a simple plain array. We're not getting an array of entities. Okay? I can debug the other way if you want. I see in your face you're thinking about that. Do you want me to explain it again or something? So this is what we are getting now, right? It's an array. We have all the rows, and the only thing missing here is the alias of the model, right? If you add an alias here, we could have something very similar to CakePHP 2.0 find operation output, right? But we don't need it anymore. So this is the output when hydrate is false, and the output when hydrate is true would be this one. Okay? You see, now we have an array, but there is an array of entities because we are hydrating the entities. If we don't hydrate the entities, we get a simple plain array. Okay? Oh. False. Right. So now we have this result. But what should we expect based on the 10 records we have in the database? How many rows should we have in the result array? 5? Because we are limiting to 5. So we should not get more than 5 rows. At least, well, we could maybe have less than that, but we know for sure that we have 10 records in the answers. So we can say, hey, we are going to have 5 there. So it's a simple assertion we could start adding here. How can we compare the expected result with the result we are getting from the tested code using assertions? Assertions is the way the functions the PHP unit provides us. There are lots of different types of assertions, and they help us to compare two things. So if those two things are not right, the assertion will stop and will tell us, hey, something goes wrong, something went wrong with that, and I was expecting this thing, but you gave me this other thing different. So the assertions are written in a way, the output you're getting using assertions will help you to fix the things that are wrong in the code. Sometimes. So yeah, we have a result. We have an assertion that is called assert equals. Well, there is an assertion that is assert count. Let's use it. It's free. So we expect 5, right? So if we run this code and there are 5 elements in the result array, the test will pass. If they're not, the test will not pass, and we will get a warning. Something, we will get an error. Something saying, I am expecting 5, but you're giving me 0 or whatever. Actually, let's make it go wrong. Like 15. Okay, this is going to fail. Oh yeah. So this array, I don't know if we cannot add there. We'll get the same. No, I don't want that. Result. Well, so Conte. So what's wrong?
I use less than or equal, and then you can pass the count in.
Well, that should be easy stuff.
It's just passing the result, and I think assert count the result for you, because it will be traversable because it's an array.
So not count. So what should we do here?
Remove the count from assert count.
Okay. So this will be a result count, right? Thank you. No. Oh yeah. It's failing because we are expecting 15, but we're getting 5. So it's not only failing, but it is also giving us a hint of what's going on there in the code, right? So let's go ahead with this. And this here. So we are going to also test the order, because this custom finder not only returns, oh, sorry. 1, 2, 3, 4, 5. Right? So we're not only getting the 5 results randomly, we are getting the latest 5 ordered by the ID. So we want to test that as well. We want to test that we are getting IDs 10, 9, 8, 7, and 6 order when we run this custom query. So we are comparing the IDs with the extract of the IDs for the result. So we are extracting all the IDs into a new array, and then we are comparing the expected array with this extracted new array. Yeah?
Put a count around the result by result count.
Where? Sorry?
Result count where you set the bar. Too up. Put a count.
Oh, yeah. Well, it's not going to work because it's not traversal. Yeah. It's counting, yeah. So this should be that, right? Expected, whatever. There. See if we run it again. Oh, let me fix that. Oh, yeah, I need to add that. This is in utility, so what? Oh yeah. Oh. Thank you. Okay. Finally. So yeah, we're testing. We're getting 5 results. We're testing. We get those results with the expected ID and the expected order for the ID. And we are also testing that we are getting those keys, user, question, and question type option. We are getting those keys present in the result array, because we are using contain for those. So they should be there. Well, we are only checking that they are present on the first result. Maybe in the second result they are not. But okay. Any question so far? Question?
When I was told unit testing, I was always told that your assertions is a code smell should be broken out into separate tests. Is that true or false?
Yeah, we could break this into specific tests for checking specific things in the result, or but I mean, because we are testing a custom finder, I tend to use to pack everything, because it's a specific function, and I want to check that the output of this specific function covers me all those assertions.
Would you not load the data from the fixture and do an actual comparison to 2 data arrays?
Yeah, you could go.
Because like, if you've got a contain, you want to make sure that the contain
Yeah.
data is also attached. Sometimes just having a key, if the IDs don't match, you
Yeah, we could improve a lot this test here. For example, detecting the right IDs for the user are there, detecting, well, a lot of other things. We want, if we want to do it right, but this is a super first approach. So just doing something that works, so you don't have the feeling of you can go home now and start testing your models, because it's super easy to do. And it is. I mean, most of the things are very easy to test. Keep in mind here, for example, keep in mind some developer in your team needs to, or doesn't need anymore the question for this custom finder. He goes to the container and remove question. And maybe his part of the code is working, but your features are breaking because you are expecting to have a question there. So because we have this unit test, his change will break this unit test, and he will not be able to do such kind of changes. So we are preventing bugs that maybe are there hidden because nobody clicks on the little button on the right that shows this feature. Okay? Right. So I think we have time for, we have all time. So I would like you to do something on testing today. So why don't you add a new method into the users table to count the number of active users? You can call it active users. And then write a test method for active users. Go ahead. I give you 5 minutes, and I'll do it. Yes, I should be able to, but I don't know if I have my user in the vagrant box. So I need to put my SSH key there and add the remote. I will do it today, no, don't worry. Just copy paste everything and so the first thing you could do is to create a new public function, active users, in your users table. This function should return an integer, that is the count of active users. So how could we write this kind of query with the new ORM? I want the count of active users. Anyone? I'm gonna help you. Anyone? Okay, I'll do it. So this is the way we could retrieve the count of active users. We're using find, we're getting a query object, then we're setting a where active 1, and then we are using count. By using count, remember we are executing the query against the database, retrieving the final count as an integer, so we are returning an integer. Okay? And now I want to test this function. I'm going to bake quickly a test for it. I'm going to bake a fixture for users. I'm going to bake a test. Table users. Okay. Now I'm going to edit this unit test. Right? Okay, we have two methods here because we have two public functions on the table, so that's not a mystery at all. And we are going to fill the test active users. How? If we follow the instructions, we will have a expected something. We will have a result that is actually calling the code we want to test, and we have an assertion or more. It's super simple. How could we test this? How many? Yeah.
This uses the active user.
Yeah. Right. Is the users?
You don't need to expect it, you just assert count them. No, assert same.
Assert same. Why not? Well, okay, equals. These users, active users, okay? And what's the expected result? 10? They are all active, or yeah, default is 1, right? So 10. you could actually add a message here if you want, saying there are no 10, or I'm expecting 10, or whatever. We don't need this anymore. Oh. Nope. So go back one folder and run the vendor users. Okay. We had another test on top of that one, so let me fix that. Yes, because we need. That's a good point. We are not testing it right because we have the wrong fixtures this time. We need to add a fixture, at least, who is not active, so we can ensure like we are doing the right thing. Because if not, we don't care, and it always passes. So let me fix that first. This one. I like the green bars at the end of the day. We're not testing it. And let's provide a fixture to possibly break our test. Users. So actually, I'm going to set active to 0, see how it fails, and then fix it. It's failing. I was expecting 10, so I'm going to spec 9 instead. This kind of message is silly. I'm not adding anything new there. Right? You see, this is super simple example, but I wanted to show you the process of building up a model test. Think about the result, think about the expected result, dealing with fixtures, and calling the code, getting the result, and comparing using an assertion. Okay? Questions so far? Well, I think we have 2 minutes left or so. So if you have a question, is now the moment to. Yeah.
I just ran the result, the active user count, and then just did a cert internal type integer just to make sure it was a number. Because if you've got no active users, it's still a valid test.
That's a good thing too. To ensure the type of the result is what we expect.
Function says it returns an integer, you want to make sure.
Yes, that's a good point. It's a good practice to check the result we are getting is on an expected type, because maybe this function is returning null somehow in the future or something. So we should ensure that this function will return an integer. So we should check the type of what's coming, because maybe it's an array or whatever. And maybe the test is passing because, I don't know, we're doing some weird things there and it's passing, but it's good that we assert the type of the result is what we expect. Thank you. That's a good point. Any other question? Okay, then I'll be around. If you have any other thing you'd like to tell me, feedback is, yeah?
Does it require to, I have an error message that some other fixture is missing. Does it require to make core fixtures?
Yeah, you can use the core fixtures if you want. If you don't want to add a fixture by yourself, you can rely on those core fixtures are already there and import those fixtures in your code. Okay. Yeah. Well, thank you. Thank you very much.
Hey guys, so lunch is going to be served in like 2 minutes. Same as yesterday, if you've come early and you're a conference attendee or speaker, there's lunch available. I think it's 28 euros if you want to go. I think everyone here is more or less workshops, right? So I don't know if that applies. Yesterday we had the drinks and tapas. We had like a load of coupons and there's a load left. So we're going to repeat tonight. So if you want to head over to the bar, from 9 to 11, you can get a free drink, and your drink comes with a little plate of food. It's called a tapa. So you're probably all hungry, so go eat.